Welcome back to Trigonometry again. This is part 10. We are going to discuss the questions involving 2 dimensions and 3 dimensions. Watch very carefully. A good question from 3 dimension. Matthew and Paul stand some distance away from a building AB. The height of the building is available. It is 12 meters. The angle of elevation of Matthew, that is from M to the top of the building, is 40 degrees. And also the angle of elevation of Paul from the point from P to the top of the building is 45 degrees. Another angle, MBP, is also available, 55 degrees. The question, calculate the distance between Matthew and Paul. Beautiful question. So we have to solve for MP or PM. In the triangle MBP, we have only one angle available, 55 degrees. So it's not going to help us to solve for MP. That's how we have to start thinking. Now, we have other triangles here. Look at the triangle ABM. From that triangle ABM, we can write tan 40 is equal to 12 over BM. Our intention is to get the length of BM. Therefore, BM is equal to 12 over tan 40. On the calculator, we get 14,30. Immediately, you can write that. Okay, better write 14,30 on that side on the diagram sheet so that we will be faster in answering this question. Next is the triangle ABP. Tan 45 is equal to 12 over BP. We are going to solve for BP now. So BP is equal to 12 over tan 45, which is 12. So we got BM and BP now. And also the included angle is available. Okay. We also write 12 here. So 12 and 14,3. So we use our famous cosine rule here because we have two sides and the included angle. The angle in between those two sides are available. Immediately we must realize that we can apply cosine rule. Go to the formula sheet and copy that. So if you want PM square, how do we write? PM square is equal to BP square plus BM square minus 2 times BP times BM times cos of 55 degree. Substitute the numbers and then use the calculator. We get 151,6386. That is PM square. What is PM? Square root of that number is 12,31 unit meter. That's how we solve these type of questions. Another good question. AB represents a vertical netball ball. 2 players are positioned on either side of the netball ball at points D and E. Another player is at the point C. The angle of elevation from C is X. Angle of elevation from E is Y. Also, we are given the distance from B to E. BE is K. Now, we are going to look at the question. Show that AC equal to K times tan Y over sin X. So, angle Y and angle X, tan Y and sin X are involved. So, we go to the triangle straight away. We can immediately look at, in triangle ABE, we write tan Y equal to AB over BE. Okay, BE is available. Tan Y is AB over K, and then we can solve for AB. AB is k times tan y. Again, we use that one into the second triangle. We can write sine of x because we have sine x in the question. So we must have an eye on that. Sine x is AB over hypotenuse, that is AC. Okay. From there, we can solve for AC. AB over sine x equal to k times AB is k times tan y over sine x. We got the answer. Okay. A pilot is flying in a helicopter at point A, which is h meters from the ground. Look at that. That is the position A, and this is the ground at B. The height, you can see h. And the pilot determines the angle of depression. Look at the object is down. So it's called angle of depression. Now that is 30 degree. Again, the distance from the helicopter to the control room C is also given in the question. That is 3h meters. And one more information. Angle BAC is 2x. So these are the given information. We are going to now look at the question. Determine the distance AB. That is question A in terms of h. So how can we calculate AB? We look at the triangle with AB as a side. AB is the hypotenuse. But we have only 90 degree and h. We have to think about the angle ABD. Angle ABD is 30 degrees because the horizontal and this line, horizontal and the ground is parallel. Look at this horizontal line, and here is the ground. So that one is an alternate angle. So if the angle of depression is 30 degree, angle ABD is also 30 degree. Now we can use hypotenuse can be calculated. What ratio we will use? We have the opposite side. So we write, okay, in triangle ABD, we can get sine 30 is h over AB. From there we solve for AB. AB equal to h over sine 30, which is half. H over half is 2h. Okay, that's how we get. Question continues. Show that the distance between the strange object at point B and the control room C, look at this one, BC, is given by h times root of 25 minus 24 cos square x. So we have to solve for BC. Look at the triangles available. Here is a big triangle ABC where we have AC, and again in the previous question A we calculated AB, that is 2h. We better write that. Now we have, look at this one, two sides, and the included angle is already available, that is 2x. So we can apply the cosine rule and we can calculate BC. That's our technique. We go to the formula sheet, take the formula cosine rule. Therefore we substitute all the available terms. 2h whole square, 3h whole square, minus 2 times 2h times 3h times cos 2x. That's all. Then we simplify as much as possible, but look at that. We have cos 2x. What is our question saying? We want cos square x. So cos 2x will be replaced or substituted by the double angle formula. From the formula sheet again, which one we choose? We have three options. So we better choose 2 cos square x minus 1 because we are expecting the answer in that form. Therefore we simplify again. Multiply by 12h square, we get 24h square Minus 12h square minus 1 gives us positive 12h square. 13h square plus 12h square giving us 25h square. We got it. Now that is BC square. Therefore BC, okay, we take h square outside because the question demands in that format. So BC equal to square root of h square is h and the other terms in the square root. So we are finished with the question. Another good question. AD is a vertical structure and we can see BCD in the horizontal plane. AB is equal to 2BC. It's a good information. And BC is K. Therefore, immediately we can write in the diagram sheet that is BC is K. So AB will be 2 times K. 2 times K. We are going to use that. Now what is our question? Prove that AC is equal to K times root of 1 plus 8 sine square theta. So we are going to solve for AC. AC is here in the triangle ABC. We have angle ABC is 2 theta. BC is equal to K and AB is 2 times BC given in the question. Therefore, that is equal to 2K. So we are going to use the cosine rule. Now we have K and 2K here and the angle in between is 2 theta. We can use cosine rule. Okay, we can save, spay. Another step, use the square root, substitute very carefully and we simplified step by step. Remember that it is 5k square minus 4k square times, don't subtract 5k square minus 4k square, don't make mistakes. K square is common. Simplify again. What we do, cos 2 theta is now replaced by our double angle formula, 1 minus 2 sine square. Why do we do that? We don't need any 2 theta in our answer. It is sine square. So we use the option with 1 minus 2 sine square theta in the place of cos 2 theta. Again, remove the bracket, we get, and k square, square root of k square is k. And inside the square root, you get 1 plus 8 sine square theta. That is what we want. Question B, calculate the value of AC. If k equal to 139,5 theta equal to 42 degrees, substitute into the formula and use the calculator. We get 299 meters. Another good question. Here is the diagram, very clear diagram, and the question is prove that QM equal to RM. So where is QM? We look at the triangle, and where is RM? We look at the triangle. We have right angle triangles, 2 right angle triangles. So in triangle PMQ, tan theta is equal to x over QM, and therefore QM is equal to x over tan theta. In the triangle PMR, again tan theta is x over RM. Therefore RM is equal to x over tan theta. Look at the answers. Both are equal to x over tan theta. Therefore from 1 and 2, question 1 and 2, QM equal to RM. Question B, prove that tan theta equal to cos beta over 6. Okay. Now beta is coming into the picture. So the triangle QMR. We already have QM equal to MR. We have proved it. We use that information and we have the angle beta. QM equal to QR. Look at that. QM is equal to RM. Therefore, the base angles of this triangle must be same. If this angle MQR is beta, then immediately we can write the other angle, base angle, is also beta. Okay. Now, we continue with this third angle. What is the third angle then? Beta and beta, 2 beta. So the third angle is 180 minus 2 beta. Okay. We use this and we apply. What's our intention? We want to calculate, okay, tan theta equal to. So we go for sine rule here. Sine beta over mr. Sine beta over mr is equal to sine qmr, okay, over 12x. Therefore, what is qmr? 180 minus 2 beta. We write that, and mr is x over tan theta. Theta is coming now. 180 minus 2 beta. Sine 180 minus 2 beta is sine 2 beta, double angle. So what we do? We will use our double angle formula here because there is no 2 beta in the question. Now sine 2 beta, which one? 2 sine beta cos beta, only one option. So sine beta is replaced by 2 sine beta cos beta. Now tan theta is simplified, sine beta cancelled, x and x cancelled, 2 into 12 is 6. So we get tan theta is equal to cos beta over 6. And we come to the answer. That is part 10 of trigonometry. Hope you enjoyed this video. Practice more questions from the question papers and prepare for the exam. Good luck.